Today, I want to talk about something in AI that I feel not enough people are talking about.
Agentic AI, which is agentic AI.
Agentic AI is so
Agentic AI first.
Agentic AI is this big shift for organizations.
And optimize agentic workflows.
Is it more agentic in nature in the sense that
So, everyone's saying agentic. It's the next multi trillion opportunity which will justify the multi billions of investments that AI companies are currently asking for. But what really is it? So, agentic AI is basically giving software a goal instead of a script. So, instead of telling a system how to do something, we tell it what outcome do we want. It could be like resolve this refund or investigate this incident, prepare this report, and then it reasons itself, leverages the tools and context and knowledge available to it to pursue that particular outcome. But the problem is, at its heart, are still LLMs, which are probabilistic. So, how do enterprises let something probabilistic run inside their systems? This is what we'll find out today. Let's dig deep. So, basically, it's giving software a goal instead of a script. Let's take a simple example. Let's take a refund request. Imagine your company processes 10,000 refund requests every month. There are three ways to run that system. One, the easiest is humans. A support agent reads the message, finds the order, checks the refund policy, and then processes the refund. So this could take like, say, 5 minutes. And that would cost about $5 per refund on average wages. The advantages there is the humans are flexible, they can handle messy edge cases. But the problem is it scales linearly. So if you need 10 people to do 10,000 this month, and suppose your refund requests double, you need double the number of people. So the costs vary linearly. Now, the second way to do that is automation. And now this is what a typical RPA type system would do. Instead of human, a bot would follow a script. It would be open inbox, extract order ID, check refund window, trigger refund, send template response, right? Simple rule-based stuff. The advantage is it's cheap, it's deterministic, and fast. But the problem is what happens in production. If a customer just says, hey, this didn't work out, or he doesn't send the order ID, the bot stops, right? The order ID format changes, the bot stops. Refund window policies changed, customer sent a screenshot instead of text. It's very fragile and brittle. Any changes in the underlying systems or the workflow could break it. And so RPA handles structure very well, but the reality is variability. Now, the third way is agentic AI. Now, let's think back to the goal versus script difference. So instead of giving software a script, we give it a goal, which is resolve this refund. So now the system can read the message, it can understand the variability, it can search CRM for recent orders, find the most likely match, it can fetch the most recent refund policy, it can evaluate eligibility, it can call the right API, route approvals if some DOP is there. So it's not following a script, it is figuring out the steps using reasoning, and that's what makes it agentic. But remember the catch. Agentic systems rely on large language models which are probabilistic. They don't execute rules 100% of the time. They predict the next best action, which is how they reason. So if you let them directly run enterprise systems, things break very quickly. So how do companies make this safe? The answer is sort of like having a genius child, but it does what it wants. So the way is putting rules and systems around it to control its behavior. And that's the next section, the right architecture for agentic AI systems. So real agentic systems are not just a model, they're a stack. And each layer sort of constrains what the model can do. So the first layer is memory, but not in the way most people think. The model doesn't remember facts, it sort of retrieves them. So suppose there's a customer message which arrives, he wants a refund. The system queries from the subsystems, from CRM, from the order database, the customer profile, the refund policies, all of who return structured records. Now the model reasons over this live data. It does not guess. Now, if the CRM says the order is 47 days old, that overrides the whatever data the model remembers, right? So the modern agent systems combine multiple retrieval systems. They will have structured databases, they will vector search documents, metadata filtering, real-time queries. So the system sort of builds a context window of relevant information before the model even starts reasoning. And this is very, very important. The next layer is tooling. In the previous layer, the model fetched from the subsystems the right context and it reasoned. But the model still can't change anything. It can only suggest actions. So one of the outcomes from the previous step would be outputting something like issue refund for order number 4821 and an amount of $75. But what happens next is that the orchestration layer will intercept that. And then it will do its own checks. It will check whether the order is existing, is the schema valid, is the amount correct, are there any other policies governing the amount, and then the specific refund API executes. So the model suggests, but the system enforces, and that's the deterministic boundary that agentic AI systems implement on top of the probabilistic LLMs. Now, the next important layer is identity. Now, agents don't have unlimited power. They sort of inherit user permissions. So if a support rep can approve, say, $5,000 refund, so can the agent. If not, it can't. So access control before any action happens or before even the model sees the data is key. Now, the next layer is one of the most important, policy layer, which implements and enforces the hard guardrail. So business rules don't live inside the model, they should live outside it. So even if the model predicts an approval for a refund, the system could block it if it violates any of the existing policies which live outside the model, which prevents things like prompt injection or people trying to convince the model to give them a specific approval. But no matter what the model says, there is a check and a policy applying guardrails which lives outside the model, which ensures that policy always wins and deterministic rules override the probabilistic reasoning. And now we reach the final layer, which is to ensure that the AI and the agent is auditable. Every step it takes should be recorded. Everything should be logged, like model input, output, which tool calls, the API response, and the final decisions. This will help human in loop reviews. You can replay exactly why a refund was approved. You can audit decisions, you can compare model versions, and it will ensure that enterprise agents are in black boxes. They are observable software systems. So now we can actually define agentic AI. It's not a model, it's a system, a probabilistic reasoning engine grounded in real enterprise data, executing through deterministic APIs, bound by identity and permissions, and constrained by business policy, and fully traceable through execution logs. Without that, it's just a demo. With them, it becomes enterprise architecture. So agentic is not autonomous intelligence, it's probabilistic reasoning inside deterministic systems. And that's a powerful combination because it means something fundamentally changed. For decades, software automated steps. Now software is automating reasoning. And when reasoning becomes programmable, entire industries can change. I hope you liked it. Until next time, see you.